All right, so this is multiplication and division of polynomials with exponents. It's kind of a mouthful, but uh, this early stuff really isn't too bad. The last problem is the only one where there might be some trouble, but even then, I think you can work through it. I'm going to try to introduce at least most of the principles with these first problems, and then we'll put them all together and add like one or two extra principles on our final problem. So this first one here, we have x to the fourth times x cubed, or x to the third. And whenever you have uh, whenever you have variables that have exponents and they are being multiplied, all you do is you add the exponents. So this one, x to the seventh. Like another example, I can just write out here really quick. X to the ninth, not plus, times, that's the times sign, kind of hard to write, times x to the second is just going to add these, 11. If it's just two variables that are the same and you're multiplying them, you just add them. That is it. First principle, done. Second principle, right over here. We're doing the exact same thing, but if it's a negative, you got to remember that it's a negative. So we're adding, you get 5 plus negative 4 plus 1, 5 plus negative 4, that is 1, plus 1, x squared, or x to the second power. That's it. If it's a negative, you're just going to subtract it, basically. That's all we're doing. Fairly simple so far. This one is division. Whenever you see division, you're going to subtract. So it would be 1 minus negative 2, which a minus, and a minus make a plus, x to the third. I'll write another example out. Uh, we'll do x squared over x to the fourth power. You would get 2 minus 4. You would get x to the negative second, which it's a good thing I wrote this out, because if it is to the negative second, we don't like negative exponents. So what we can do is we can just put it over 1 and just say that this isn't x to the negative second. This is 1 over x to the second. You can just take this negative. This is another principle that we're going to use later. You can just take that negative and make it 1 over x to the second. You just flip it over, because there's an imaginary 1 here. You can erase that by flipping these over, right? It's just something you got to know. So, like another example that we could write specifically this would be like x to the negative third. That's all over 1. You flip it, you get 1 over x to the third. Drop the negative sign, flip it. That's all. Next one right here, we're going with two variables multiplied together having an exponent above them, which this is also quite simple. What we're going to do actually is we're just going to write this out. xy, that's pretty bad y, xy times xy, and you're just going to get x squared y squared. Not too bad. So that's another principle. Move over. This is where we're going to put everything into use. So the thing that we learned earlier. So like looking at this, it might be confusing where to start. Well, we got something on the outside. Let's get rid of these parentheses by doing what's on the outside. First things first, we just learned that a negative means you flip it. So let's get rid of the negative here and flip this. So instead, we're going to have negative 6x y to the negative fourth z to the seventh. That's needs to be a little higher up than that. Over. That's a very long 4. 4x to the negative second and y to the third. So we got rid of the negative there. So now this we still have this left though, is we didn't get rid of the 2. So got a 2 there. So now we can take the 2 and put it. So for this, what you do is you just take the 2, give it to each one. Right? The x gets it, the y, the z, bottom, everything gets it. Which actually, that's an easier way to do this one. Because I wanted to, like, you don't even, just don't even do this. 2, 2. Just, that's only if it's multiplying though. Don't be like x plus 5. I didn't finish the 5, but x plus 5 squared. You don't want to go over and be like, oh, that's just x squared plus 25. Because it's actually x squared plus 2x plus 25, because you have to multiply it out. So if it's multiplied, just distribute it. That's all you got to do. But if we distribute this to everything, so 6, x, y, everything gets it, we're going to end up with 6 times 6 is 36. And another thing is whenever you're taking a outer exponent to an inner exponent, you don't add them, you multiply them. So there's a 1 here. So 2 times 1 is x will be 2. So this negative 4 on the y is going to turn into negative 8. I don't like writing 8s. Hold on. I got this. Genius. And then the z will become a 14. All over 16. The x down here will become a negative 4. And the y will become a 6. So now we have this. Well, we can actually simplify this down. 4 goes into both of these, highest common denominator. So we can take 36. 36 divided by 4 is 9. And we're going to do the bottom later. Well, let's just draw this out really quick. We'll go ahead and put the 16 divided by 4 is 4. So nothing really happened with the bottom one, but it's fine. Now, we're going to use what we just did earlier with x squared and x to the negative 4. Remember that we're doing 2 and we're dividing. It's going to be minus minus 4. A minus, so minus minus a negative is going to be a positive, and you're going to get x to the 6th on the top. It's going to stay on the top because it's a positive number, and we're subtracting. Now, y, on the other hand, we're gonna go through it, but we're gonna get -8 minus 6, which will be y to the -14. And z, that's subtracting by 0. There's nothing down there. So z to the 14th as well. Now the issue is we don't like negative exponents. So we are going to remove the negative, but flip it over. So imagine that there's like, uh, there's a 4 down here, but this y in particular has a 1 that we can just swap it out with. So our actual answer is going to be 9x to the 6th z to the 14th over 4y to the 14th. And it's because we're taking this and we're sending it down there. So that was the most complicated one on these examples. I briefly introduced you to, that was an awful circle. We're doing that again. See, I briefly introduced you to all the main principles, and then, because the those main principles, separately, they're all extremely easy. You multiply, you add them, you divide, you subtract them. If it's a negative, you flip it. But it's putting them all together that can make it look confusing. But if you just work it out one step at a time, always start with the outside here. If there's something on the outside, just give it to everything, as long as there's no addition. If we have addition in here, then you have to do it differently. But we're only focusing on multiplication and division right now. And that's what I was talking about over here. If it's x plus 5, you got to multiply it out. You get x squared plus x plus 25. So just don't get confused on that. So only multiplication and division. But if that's all you're doing, then you just distribute to everything on the inside. And then you simplify it. And we had division here. Yeah, so it can look a little confusing, but you just work through it one step at a time, you'll be fine.